Hello, and welcome to today's webinar, Why Manufacturers Are Ditching Traditional MES. In this webinar, we'll be talking about, we'll give a first-hand look at composable manufacturing systems in practice, modular, flexible, and built to adapt. You'll see how leading manufacturers are scaling faster, cutting costs, and improving visibility with a composable MES approach. So today, I am joined by my two colleagues. Dr. Gilad Linger is an accomplished business leader with 29 years plus of experience driving digital transformation in manufacturing. His expertise spans digital technologies and manufacturing business systems, including IIoT, AI, and MES, to achieve high levels of operational performance. Gilad's passion for next-gen pharma 4.0 digital technologies and IoT is rooted in his early academic research on agile manufacturing systems. Geoff Winkley is a solutions delivery lead here at Tulip, focused on enabling manufacturers to effectively adopt digital transformation strategies and maximize the value of Tulip at scale. His background includes 10 years of experience in quality engineering at GE Aviation, where he honed his expertise in aerospace manufacturing. So here's the agenda for today. So we'll start off just going through some trends that are happening in MES, go a little bit more in depth into composability and what that means. And then Geoff and Gilad will go through 3 customer stories. We'll also have a Q&A at the end of the presentation. So please ask your questions in the Q&A pod to the right of the screen, and we'll answer those questions at the end. So with that, I'll hand it over to the team here.
Thank you, Jen.
Thanks, Jen. Hello, everybody, and welcome to this webinar. I'm going to kick us off here. This is going to be pretty conversational with me and Geoff, and we really look forward for your questions and dialogue. I know it's webinar style, but we like to do it as conversational as possible. So, starting off with, there's a buzz in the industry. I think it's pretty clear. The MES landscape is evolving. I would say it's even transforming, and it's indicative, by the statements from the analyst community. Like, you may love them or hate them, and have your opinion around them, but they're all, they're sending the same message. Something is happening. The MES industry is in a change. We have to balance from an analyst perspective. They always want to balance, the traditional vendors that they are, but they understand that things are happening, and you can see the statements there. We like to in fact say that it is transforming. It's transforming into something that is new. Names don't matter that much, whether we call it MES or not. It is going to look very, very differently, and it's really the difference. And we'll in this webinar we're going to go into depth into what it is. We call it composability. Composability, again, is a term, and it was coined by one of the analyst companies, so give them credit for that. We've taken it and defined it very clearly in what it means. You can think composability is synonymous with transformation, synonymous with what we call a frontline operations platform, which is what Tulip is. But it is indicative that what we will see in the future, what we call MES in the future, is going to be very different than what MES as today. Hence, this webinar and the provocative title that it obviously has. But I think everybody at this point, we're past the point where, are we talking about MES? Is it just in the cloud? We're really talking about something that's very, very different. And this very, very different, as the analysts say, includes bringing in new technologies, but what we'll do in this webinar is go really past the technology and say, not only is it new technology, it's a new approach, and then we'll also show you what the impact are to the customers, how they're using it. And with that, I'll hand it over to Geoff.
Yeah, thanks, Gilad. So I think a key tenet of this transformational change, right, is the move to the cloud. So this is not novel to the manufacturing space, the operation space, right? The move to the cloud has been a trend, throughout all industries for some time now. But I think we're really starting to see this ramp up. looking at one of the, Gartner statistics here that says only 38% today of MES installations are in the cloud. Yet we expect by 2030 that 75% of companies are going to be running their operations in the cloud. And the reasons for that, I think, are pretty obvious, right? The ability to scale without having to deal with, costly server upgrades, have to deal with these large events where you may be adding new production lines, new sites, new users. With a cloud platform and the microservice model that it has, you're able to kind of scale quite easily, right? And I think the other big piece is to just have a system and a platform, right, that is always on, always up, and kind of always up to date. And so this trend, we're seeing, throughout the customer base we work with, and I think it's only going to accelerate and continue. The other large trend in this transformational change, I'm going to say, is open ecosystems, right? It's kind of becoming an expectation for any new piece of software that you add to your industrial tech stack, that it's able to, integrate and communicate with the other systems that you have, right? I think the days of having this vendor lock-in to a particular platform, a particular protocol, are behind us. And we're really seeing this open ecosystem concept being adopted, not just by industrial customers that are consuming these technologies, but by the technology providers themselves, right? It's a competitive edge to be able to say that you can, plug and play into your existing tech stack, and, kind of ensure that you're really going to focus your budget, your brain power, and actually solving problems and not just integrating these systems right between each other. So that could be, open APIs, following some of the standard industrial protocols. All of these, concepts are part of this open ecosystem idea. And we're really seeing this, again, throughout many different industries, but more so recently kind of in the operations and MES space. Lastly, the native AI capabilities. It can't be a webinar in 2025 if we don't mention AI, at least a couple times here. So I think we are starting to, really get through that trough on the adoption curve and really start getting into the point of adopting these tools to actually be useful in an operations environment. With, I think generative AI and being able to, compose things like work instructions, kind of becoming an integral part of this, composable MES concept. These tools, as they proliferate, throughout, people's lives inherently, they're going to want to be able to, ask the same questions of their manufacturing data that they're doing today of, how to, solve all sorts of various problems and whatever other search queries that people are putting into ChatGPT today, right? There is no reason that your manufacturing industrial, data should be siloed, away from these tools. We're, seeing this more and more, and I expect this trend to kind of only continue from here. It's just going to be one more pillar in democratizing innovation on the shop floor as we, put these high technical tools into the hands of people that could really get value out of them. So we talked about the drivers from a technology perspective. So, I mean, there are, if I know all of you guys are very aware of everything that's going on from a technology perspective and what we now call the AI revolution, we call it the digital space. So that's going on. But there's with that, in the last 5 or so years, there's also some huge impactful events that are happening in the business environment. And we won't go into the detail of it, everything from COVID to what's going on right now in the world. What it means is that there's change. There's change in technology, and there's change in the business environment.
And what we're looking at as we look into the future, that change not only is not going away, it's accelerating. So when we look at the environment that you're in a manufacturing space, which is obviously the confluence of technology that we produce, technology that we use to produce, and this change in the business environment, we have to look at adaptability, right? The change now is constant, and therefore adaptability is crucial. And if you don't adapt, then basically you're going to go out of business, right? And think about simple things like supply chain, the supply chain volatility that's going on. You can't rely on your supply chain being what it is today and what is going to be tomorrow. Everything that's going on in the political landscape and the wars that are going on. So the question then is, how do we thrive in this constant change? So the idea of adaptability is not only just to deal or be proactive with change, but use change as a competitive advantage to your business. And if that's what you're trying to do, that means that the systems that you use to produce with, the technologies that you use to produce with, they have to be adaptable. They have to be changed. They have to give you the power to change on a dime, to change quickly. And that is at its core what composability is.
Right. I mean, just to add on to that, Gilad, you think about all the quote unquote black swan events we've had over the past 5 years, right? Between COVID, between a container ship getting stuck in the Suez Canal, like these, I feel like even just from my personal experience, I've never heard so much about supply chain and about even shipping containers in the news as I've heard, over the past few years. And that is that constant change, this, new environment we're in. And then you add on, the change in the regulatory landscape, right, that's happening. So I think that's a fair point to say that change is kind of the new normal.
Yeah, exactly. Yeah, I like to use a quote from Clint Eastwood that says that if you get used to change, it's actually quite comforting.
Yeah, just come to expect it.
So let's a quick look at the poll here. Thank you very much for answering the poll. It's kind of spread. The highest rank is not great. It's too rigid from an MES perspective, and that's a great way and a great segue to bring in the notion of composability and how that is going to resolve and how that's going to give us the adaptability that we're looking for. So tell us a bit more about composability, Geoff.
Yeah, this is a word, right, that gets thrown out a lot. So I want to, take just a few moments here to actually kind of bring it back to home. Like, what does composability actually mean? How can it actually help you? So going to start off by, I would say, one of my favorite visuals that I've ever encountered in my professional career. I like to always, ask people a question like, what is an MES? And follow up that question with, take your concept of what an MES is and go and circle, the bubbles here that actually fit into that box that you have predefined as an MES. And I think what this visual really does is kind of show that the challenges that a manufacturer faces, the challenges that exist in an operations environment, and this is across industries from general manufacturing through life sciences. The challenges that you face are inherently, overlapping and interconnected, right? And I think a great example and an easy one for people to understand, if you look at this chart and think about an andon event, right? So an andon event, there's an issue in your operation that needs attention. So, that may be a issue with a work instruction in which they need, help from a manufacturing engineer to resolve the issue. That could be an output from your machine monitoring, where a machine output a specific fault code. And then all of those events also affect, your OEE as you're managing performance, right? And so if these are, divided among different systems, it's going to be very hard to be able to make these, connections and understand how you need to make your operations better, right? And I think, trying to have these point solutions to solve some of these specific issues that you may have, kind of goes against the reality of the environment that most companies are actually operating in. So I'm a big fan of just this visual that really resonates with a lot of people that see it. Interestingly enough, when we kind of look at how our customer base today are using Tulip, we're seeing that about 58% of our customers, so more than half, actually have more than 10 of these use cases in production, right? So that means that they may be solving, employee and operator training along with their e-logbooks and their Kappa management, right? All within Tulip. And I think probably even more interesting than that is that, close to 90% of Tulip customers have kind of what we would all refer to as traditional MES, use cases running inside of Tulip. And that may be some sort of, EHS, audit to monitor safety equipment. It might be managing inventory for small scale manufacturer or performing, a CMMS, maintenance use case, right? All within Tulip to manage, maintenance orders, preventative maintenance, and things like that. I think it's very interesting to see not just the numbers, but the relationships between these use cases that you obviously know in reality as you spend time on, a shop floor. You understand that, your line clearance, of course, needs to be part of your historical records of a particular batch of product that you make. But, to actually see it in the data, I think really, drives that point home. And so again, this concept of, composability, right? So we could start with this, visual here of a shop floor, right? That's made up. The one thing I don't like about this visual is that it's a static photo. And I think we all understand that there is not a manufacturing environment in the world that is static at all. But again, this drives home the point that what you see here is just one representation, and inherently every single shop floor is different. I've had the privilege of, probably walking, 300 shop floors in my career here. And, the one thing that you come to understand is, yes, you will see a lot of yellow lines that outline the work that's being done, but how they operate, how they communicate, what's a priority, how product moves, how data is recorded, how machines are integrated, how supervision monitors and addresses issues is all, fundamentally different, right? They're all slight snowflakes. And so when we, think about what a composable solution is in practice, right? It's really addressing the overall business objective, but, tailored and configured to the environment, the people, the position in the facility that you're actually in, the user persona that's going to be interacting, right, with the system. So, for example, here, we're looking at many different areas of a small little factory. How a person interacts with a particular solution in a material warehouse is going to be fundamentally different from how an operator interacts with the system when they are assembling product. And so, we really want in a composable solution, the actual interface and the application itself, is designed to kind of be a digital twin of that particular physical environment that person is working in, all in the service of a larger, business objective to actually solve a problem.
So we're going to talk about a frame of reference of what is composability. So Geoff gave you a picture of what it may look like and how you can recognize composability out in the wild, in the field. But we have a very clear definition of what is composability, and this definition is very useful in many aspects. One of them being that you can actually use this to gauge whether your existing solution and your existing technology is composable or not. Composability at its core has 5 pillars. And I'm just going to go over these pillars and explain one by one, and then the framework around it. And it's important to understand that this is key. This is a key component of composability, and takes composability from a vague term to something that you can actually put your hands on and point to yes or no, this is composable or not. All 5 of these pillars have to exist in your solution in order for it to be composable, starting with bottoms up. Bottoms up talks about how the solution is implemented and how it evolves. When you implement a composable solution, you don't do it top down. That's an example of monolithic, meaning that you go to a problem on your shop floor, one specific area, one specific station sometimes, or one specific line, and you start by solving the problem for that line in the specific use case that it needs. So, for example, if you go to a line and that line needs digital work instructions, then you apply and you create digital work instructions for that line, station by station on the line. That's how you achieve composability bottoms up. So that's pillar number 1, and very important. And it's the question to ask is, can we do that? If I go to MES vendor X and say, can I do that? Can I go to the first station in the line and within a few hours create a solution for them? That's all it does. It's just one thing for one station. If the answer is yes, we're on the right track. Next is agility, and agility, again, one very important concept, and it brings together what we know as lean in a manufacturing environment. So we all know that lean is how production is run. Operational excellence is how we create manufacturing systems that are optimal. It was coined by Toyota, and it exists everywhere. It's a given. There is no manufacturing company or manufacturing site in the world that is not telling you, no, we don't. Lean is not for us. Lean is a thing. Operational excellence is a thing. That's how we run manufacturing. Hence, the technology that we use in manufacturing has to not only align with our lean and our operational excellence and our continuous improvement initiatives and motion, it has to support it and augment it. Hence comes the notion, the concept of augmented lean, one of the concepts that we have promoted and written a book about. So agility means taking lean and making it an integral part of how you use a technology. The technology has to simply allow you to create continuous improvement cycles and augment and support them, and you should see the improvement through that. If it doesn't do it, if it's separated, if it constrains it in any way, you're basically putting a barrier for productivity, which is part of being digital, is the increase in productivity. So that's pillar number 2. And pillar number 3 is democratization. I want to emphasize democratization sometimes is also the term citizen development is used as part of democratization. It's important to understand democratization is much more than citizen development. Democratization is about empowering people that run your manufacturing plant, that engineer your manufacturing plant, that are responsible for the operation of the manufacturing plant, the ability to use that technology for their own benefit, meaning that technology is simplified and it becomes accessible to everybody on the shop floor. You don't have to go to experts to help you use the technology. Think about a simple scenario of a plant manager needing to go to the experts to create a report from the data that whatever system is capturing. That is not democratization. The plant manager should be able to open the system, look at the data, use the data, and whatever he needs to create PowerPoint files and charts, or even for his own analysis, use it. That's an example of democratization, and it lowers the barrier to entry and bringing these technology in. And you can ask the question to your vendors, who is going to do this for me? If the answer is, we have integrators and helpers and skilled and people that know the product, versus you are going to implement the technology, that's an example of democratization. Next pillar is human centricity. Human centricity is at the core of digital transformation, is making the operators, the frontline people who are doing the work, more productive. We talk about technology that serves the operator and not the operator that serves technology. If you have a system where the operator doing his work with 2 hands has to pause, go over to the screen, and tell the system what he did, that is not a human-centric system. It needs to be integral to how he works. And we're talking about simple things like just creating content that is visually appealing or helping him do things in the right place, to devices and features like vision cameras and all sorts of devices that he can wear or use to make his life easier. A simple example that's a bit trivial. Instead of somebody touching a button on the screen to move to a next screen, a foot pedal. How easy is it to put a foot pedal that he can press, or a button that he can press, to make the system react to something that, or advance to the next step? So those are simple human-centric thing that we need to think about as part of this. And again, you can ask your vendors how easy that is. The fifth pillar is very unique for regulated industry. It has to do with compliance. Compliance in some industries is a huge barrier to technology adoption, and hence any kind of composable system has to make the compliance seamless. It has to minimize the effort of compliance. It has to have inherent, embedded, built-in compliance. And this is a topic for a whole webinar by itself. And I think we've had quite a few webinars on this topic as well. So we'll just leave it as that. Now, putting all this together in a framework, remember, we also have to connect to the real world. In a digital system, and any digital technology that you use in your everyday, it is connected with the real world. Think about your mobile phones, with GPS trackers and temperature sensors, and the fact that you can actually shake it and you have feedback. You have to be connected. And in a manufacturing environment, we are connected. We are in the physical world, and we need to be able to very easily connect to that physical world, as well as connect to the systems that are around us. Any given manufacturing plant is never going to be new. The average age of technology and machines in a manufacturing plant is roughly 20 to 25 years. So we have to connect to all this stuff that's there anyways. And connectivity is a huge part of being composable. On the top, we have digital maturity, and that's in how ready are we as an organization, both technically and organizationally, from a culture perspective, to adopt these new technologies. That is something that, again, this is a topic for a webinar series in itself, but the organizational change and the readiness part of it is super important. Being a mature organization that's ready to adopt these things is of immense importance. Bringing all this together, we talked about cloud technologies being in the cloud as important. That's infrastructure, and it's kind of a given. Connecting to the edge, so having edge components in this architecture that allow us to do that. And obviously the cognitive aspect, as we talked, as Geoff brought up, AI and the AI revolution is here. AI should not be an afterthought. It has to be embedded, part of the system, in the system used, and giving you the value that it needs. Now, what does all this result in? It results in time to value. So, at its core, why are we so interested in digital transformation? Why is all this new stuff so interesting for us from a manufacturing perspective? It's not because the technology is cool. It's because everybody at the C-level has recognized that this is a order of magnitude change in productivity. If we adopt these technologies, we're going to be not single digit, but double digit and triple digit more productive than we were before. This is a paradigm change. It's like going from steam to electricity, and electricity to the electronic age. It means that if you do not adopt these technologies, you're basically, and you don't have the adaptability that you need to deal with the market trends that are going on, you may not survive as a company, and that is why it's so important. So therefore, speed is important. And if you can see that this is an exemplification of this bottoms-up nature of things, what's important to see, to look at in this graphic, is the time scale. The time scale for monolithic systems is measured in months and years. It takes years to get MES systems in. I'm assuming many of you have experienced the implementation of MES systems or any kind of monolithic systems. It's painful. It takes time. And
you're not sure what you're going to get when you actually turn it on.
Exactly. So in a composable system, you're starting to get value immediately. You do a small pilot. You start small. Within weeks, you have something running in your manufacturing plants, and we'll show you examples. This is not this is not a fairy tale. This actually is happening. It is happening with our customers, and we'll exemplify that. And again, a very, very simple way If you have anything, if you take anything away from this webinar, I talked about the 5 pillars of composability. It's just a simple question: is how fast can we start getting value? If your vendor is telling you this is going to take months and years, you do not have composable technologies. You will not be able to adapt. It has to be measured in hours, days, and weeks at a maximum. Let's take a deeper dive and look at a U-cell shape and what a composable set of apps may look like in a cell. So here we have the standard U-shaped cell, in a manufacturing plant, and we have 7 operations, and we have indications of 4 operators that are operating within this cell. So what we can see is, and of course within the cell there's going to be a supervisor and many other things. So let's go to the round dots are representative of an app. So what you can see here is operator A, that's in operation number 1, has an app, the gray app. It's called operation number 1 app. What is that app? That is an app that's tailor-made specifically for that operation, meaning that operator, when he looks at the app and when he interacts with the app, it's built, connected to devices he has in that station, and uniquely showing him what he needs to do at that station. And that app, operation app number 1, is and may look like completely different than operation 2 and 3 app, where you have operator B that's tending to 2 operations, 2 and 3. That app, is going to be very different. Why? First of all, it needs to support 2 operations, and an operator that navigates, that moves between the 2, may have very, very different devices and tools that it use. And therefore, it doesn't have to be the same, right? And that's indicative. So here we have what we're building here is content, or we call them apps, and they can be multiple. It doesn't have to be one. That is exclusively helping operator A and B do what they're supposed to do in that operation specifically. And as we go on, you can see that there's different apps for different operations, each tailored to what they need to do, including apps for the supervisor, because the supervisor needs to look at very different information than any of the operators. He may have to prioritize work orders and other things. We may have a work order app to help the planner create or set the priorities of, or schedule the orders. There's some dashboards, either at the line level or at the plant level. Again, these are different apps that do different things. So what you can see here is an exemplification of a solution where content is built specifically for operators, and it's not that an operator has to use the same type of screen for everything, and it doesn't have to be busy with all the features that needs to be for a complete cell. That's an example of apps working together in an operational environment. We also have these notions of tables. So the tables is what's kind of the glue that brings together the information between the apps. It's essentially how the apps collaborate. Think about an operator together with the app as being an agent or an entity within the system, and it's sharing information across the different apps. So when operator A does something to unit, then anybody who's using the system can see that unit has changed, or there is something going on with that unit. At its core, and there's obviously very much more detail in how we do these things, but again, from a high level, what it gives you is a way to understand if you have a composable system. So if you walk to your cell and you look at the systems that are there, you either have one screen for everybody in the cell, like a terminal they need to go to, or everybody's looking at the same type of screen with no change. It's not catering to the operator. You know that you don't have a composable system.
I think one other thing, if you just go back for a second, Gilad, again, this is like a snapshot, right? And so, as you were, if you were to have a digital solution, you start then getting these new insights and this new data. You may find, for example, that you do not have line balance between these 7 stations, and you may decide that you need operators A, B, C, and D, and also operator E that's going to be at station 5 by themselves. You need a solution here, a composable solution that's going to allow you to take what was operation 4 and 5 as a particular app or as a particular interface, and easily split that up, so that this new person, this new operator can be a part of the line, and you can continue to have your flow here. And again, this just goes back to that agility concept and the ability to adapt to the change and the needs of the particular operations floor.
Yeah, that's a very good point. I mean, most of these cells typically have stations on wheels and can be reconfigured at any time. These apps will go with the station, or you just build new apps, and again, are split between the two. So 4 and 5 get split. You split the app, and now you have 2 apps, one for 4, one for 5, and move it somewhere else.
Yep. And so taking that initial view and kind of zooming out a little bit, what does a composable solution look like when you're doing, deployment and planning? Because I think too, something that kind of gets opened up is, with a composable solution, you really have the ability to scale kind of both vertically and horizontally in this chart here. So that may mean that you are we'll do and-on management again, coming up with an and-on management system, developing that and scaling it horizontally to many different sites. And this could be also locations. It could be production lines. It could be product lines. But again, scaling that horizontally, or it could be, focusing on one particular site, one particular production line, and really starting to develop many of these use cases. But it does start with, planning that initial scope. And again, it really comes down to understanding, what your, business objectives are, what the problems are that you're trying to solve, not taking a traditional, piece of software and just trying to mold and fit it into your existing operation. Really having that first principles approach of what is my business needs today? What's the environment I'm operating in? What does the future look like? What do I need to improve to, increase margin, to increase output, to meet customer demand? And, mapping that to use cases that are going to actually help solve that problem.
So now it's time to start looking at, what is it in practice? We'll go over a few customer cases, but I just want to start with a picture, kind of a high-level picture of results from real life, from some of our customers in real life. So, the numbers speak for themselves. I think one of the things, if you take a look at this slide, notice it's double digits. These are impactful double-digit order of magnitude changes that our customers are seeing. And that's indicative of composability. As you notice, composability is not about, I think we've made it very clear that composability is not only technology, but also the approach, hence the 5 pillars. So if you do this right, this is the result. So, being able to, Stanley Black & Decker, be able to, within 3 months, deploy MESs to multiple sites. I mean, that's unheard of in the traditional space. That's the speed by which you get that. The 70%, outside medical, 6 months in with validation. That means that, they went live with a system in a greenfield facility that's validated, running, producing medical device that does, that are sold to customers. With defects going down 70%, nearly 100% review of EDHRs going, like literally EDHRs that are or devices that are by exception released to sales in the market. That is, again, indicative of what you get if you do this right.
Yeah, and I think too, what's interesting here is the results are also quite varying. Between improvement in quality, improvement in review time for a EDHR, right? Decrease in scrap. Some is increase in, productivity. There are various metrics, right, that are on the screen and show the result of how this composable solution supports many different, objectives.
Yeah. And key here, adaptability, right? This sets the foundation for these companies to be adaptable. They, and if you talk to them and if you talk to their executives, they feel confident that whatever happens in the market, they are able to adapt. And some of this we can share and some of this not. But, I'm talking to the executives in these customers, especially around tariffs, et cetera. They were not worried. They know how to adapt. They know how to move. They say, that, if they need to move facilities, even between regions and between borders, they can do that. They feel confident that they can adapt to at that space, and that's a very unique position to be in as a company. Okay, we're going to go in a bit in depth into three use or stories here from our customers. We'll go through a medical device manufacturer we cannot name, and then Crestline, and close with InnovaFeed. And with that, maybe Geoff, start us off here with medical technology manufacturer.
Yeah, thanks, Gilad. As Gilad said, top 10 medical technology manufacturer that has, various production sites spread kind of throughout the world. Many of these sites were from, acquisition, right? So they had merged and acquired various different customers, and they kind of faced this inherent problem of having, many different technology stacks divided throughout all of the sites, most notably many different, MES and ERP systems. They also were mostly paper-based at a lot of these sites when it came to the actual operations and their physical device history records, and really didn't have, good visibility into what was happening. Knew that there were kind of long lead times to do paperwork reviews. They had many different GXP errors, GDP errors that were very costly. And also another interesting point was like a high turnover of contract operators. And so this customer, adopted a composable platform in Tulip and really saw some really major gains. So I think the most notable thing is their ability to, deploy similar use cases from one site to another quite easily. And so this was kind of the horizontal scaling that I discussed a bit earlier. So once they had created EDHR framework, right? They were able to kind of, take that concept, take that data model, take those templates that were produced, and, shift those over to be configured for another product line, potentially in an entirely different part of the world, and potentially with a workforce that spoke a different language, right? And so, this is something that, a composable system, allows you to do. And 3 to 9 months for a validated, EDHR is actually is quite good. And again, this kind of goes back. This is the same customer where one particular site had a specific need about flagging, potential upcoming material shortages, and they, using the system that they already had, they had one site, built locally. Again, this democratized effort of identifying a problem that they were facing. They were able to, very quickly build a dashboard that ended up being adopted by their Center of Excellence, their COE, which is a small team that helps coordinate between these sites and actually take this content and deliver it, to other sites, which resulted in, increased uptime and then, decreasing the number of events of material shortages that actually caused outtime. So really interesting, both regulated and non-regulated use cases in a large medical device manufacturer. And, this is a particular customer that is only accelerating their growth. So thinking back to the chart Gilad showed earlier, where, starting small and continuing to build up, we're starting to see this chart kind of start to go exponential as these various use cases, templates, dashboards, and solutions get proliferated around their enterprise. So really, really interesting story there. Going to the general manufacturing world and discrete manufacturing, want to take a moment to talk about Crestline. So Crestline is a As you can see here, very obvious what they make, a specialty vehicle manufacturer, specifically ambulances. They had the good business problem in that both their technology and I guess the market demand for ambulances had increased greatly, and they needed a new system to replace their antiquated in-house built systems and paper processes that allowed them to get more output out of their production lines that they had. And so we were able to have a really, really interesting story here with this customer. So they engaged the Tulip professional services team. Team went on site there, and within 24 hours, there was a application, prototype app that had been built that was in testing live on the shop floor. So there's a little picture there of the team that actually took something from the Tulip library, deployed a very simple production visibility app, simply so their supervisors could actually monitor the activity of what was happening on their floor, address the downtime events faster, understand what cycle times at each station were, so they could potentially do line balancing or understand where their bottlenecks are. They knew they had problems, but didn't always quite understand like maybe the exact location that those problems were occurring. And so that 24 hours, kind of their first app, and in a month, had deployed that solution. And again, this is that, speed that is possible, with this technology, and that time to value, displayed in reality. And so this is just the start. This customer continues to expand to more and more use cases. So doing, quality management is next. So, moving all inspection checklists into the platform so that they can start trending, numerical data, understanding first time yield, creating Paretos of defect codes, understanding where their quality events are actually slowing down production. Again, all in support of their overall objective, which is to meet customer demand that they needed to adapt to very quickly, right? They're only, these customers, only have so much patience, right? And when you are in a competitive marketplace, right, you need to be able to adapt to continue to be a leader, in your industry.
Yeah. So the last use case here is kind of interesting and different. InnovaFeed is a company. It's a startup with a very unique technology in that they grow flies, a very unique, specific species of flies, and then basically bake them and make them into protein powders because they're very high in protein. So here you have a company that is an entrant. They're building a new manufacturing plant with a novel new technology that is a combination of biotech and farming to some extent, or animal growing to some extent, and also going into new markets. The idea is that it's for animal feed, but it is going to be human consumption as well. So they have to navigate between different types of markets. So they started, and basically the premise was they need to be digital from day one, otherwise they are not going to be successful. Adaptability for them was built into the business model. They needed it, and what we saw here is a company that embraced Tulip from day one, build it into their manufacturing facility, and are able to basically operate much better, much faster, and meet their the needs of their business environment. They're using Tulip, very widely in a number of use cases, and basically there's no paper in the plant. They're highly automated as well, so there's a combination of automation here and using features within the platform, including our automations and other connectivity tools that we have. But we like to bring customers like InnovaFeed, and we have a few others that made that decision. It's not about replacing existing systems, getting rid of paper. They are from day one digital. like many of the new technology companies that are using digital tools, and they were able to do it fast. They were able to do it with their own people, meaning that they have people within their company that are using Tulip and embracing it and using it. Okay, let's close this, and I think I can already see there's some good questions, and I want to make sure we give time for that. So, just wrapping it up. We started with trends in the market. You have to think beyond MES, and we say ditching MES. It really is, take a hard look at, what type of technology you're dealing with, what type of technology you have. If you're looking at new technologies, are they truly composable? Consider scalability in terms of is this going to give us the adaptability that we need? The bottoms up approach, empowering people at your facility to use the tool, democratization of the technology, important. And then finally, continuous transformation. Adaptability is about thriving in constant change. You need to take change as a constant and ask yourself all the time, am I putting something in here? Am I doing some technology decision that is going to tie me down and not allow me to change? Geoff, any wise words here at the end? We can go to questions after this.
No, let's devote a little bit of time to some Q&A. I think you stated it well, Gilad.
Good. So So Gabrielle, there's the questions are coming in both on the chat and on the questions and answers.
Yeah, here, Gilad, I'll ask the questions because the audience can't see all of them, so I can ask the question and give them to you guys. So the first question in the Q&A chat is, does the Tulip data model inherently support scaling vertically and horizontally? Either one of you, maybe Geoff?
Yeah. Let me start with that. So the short answer is yes. And so I'm not sure how familiar you are with the Tulip data model, but there's inherently a implicit data model that the platform is kind of built on. And there is the explicit data model, that you define, for your business. We have our, what we say, common data model that is part of that explicit data model. And yes, so scaling vertically, of course, you get to define the data model that fits your business. And then horizontally, we have tooling that allows you to, ship essentially these data models to your other facilities and sites, that may be in a, partitioned environment if that aligns to your organization. So, I was assuming that this was around the, the tables, the data model in Tulip, as opposed to, the cloud technology, from, our services that does allow for essentially infinite scaling as far as AWS and Azure will go.
Yeah, I just want to add that is vertically and horizontally, it's two-dimensional. Actually, it's more than it's multi-dimensional in the way it scales. More than the technicalities of which tables do we have and what the data is. The technology allows you for a very dynamic data model. It's as dynamic and as scalable, or it's like a spreadsheet. So think about anything that you could do in spreadsheets, you basically can do in Tulip. So it's infinitely, infinitely dynamic in that perspective. But also we come to, with our composability principles, we also have best practices and a way to look at how you should structure your data. We call it the artifact model. And that artifact model adheres to, it basically enables some of this composability principles. All this is in our university and in many of our online resources, so it's publicly available, and I would urge you to take a look at it. So it's interesting, interesting aspects or concepts. Sorry, Jen. I know we also have questions on the chat, so make sure we don't forget those. Right? Yeah.
Yep. I guess first question here is, what is the cost to develop an app, and what is the investment to learn to develop an app? Maybe Gilad, do you want to take that one?
Yeah, so let me start by stating very simply, we have benchmarks. So you ask us to help build an app. We have benchmarks. We t-shirt size apps, small, medium, large. A small app is 5 hours. A complex app is 15 hours. And again, I'm emphasizing that just to give you a quick indicative, like it's fast. It's very, very easy to build apps, and because apps again are small components as part of a bigger ecosystem, it's not, you don't need to develop whole systems. You just do one thing at a time. And then just to follow up, because there was a follow up and who builds the app, I think there was a question on.
I think it was what the question was, Gilad, what is the investment to learn to develop an app?
So again, I'm just going to give you a very simple example. It literally takes an hour to start building a first app. In fact, if you want to work for Tulip, as part of our interview process, you get access to Tulip, and you have to build an app and show it as part of your interview process. We typically give people. We tell people you need to spend around 4 hours. 4 hours logging into Tulip first time, learning how to use it, and creating an app that you can then come to an interview and showcase. That's as fast as it goes. Mm-hmm. And again, online resources, we have Tulip University, a lot of knowledge base. We have a free trial as well. It's very, very quick and easy to learn how to use apps.
We also have the Tulip library as well, where we have pre-built app templates that you can start using. And we have a composable MES for a few different industries that you can use as a starting point. Great. So next question is, are you sharing the presentation? Yes, we're recording this right now. I'll be sharing out a link after the webinar. And then let's see, question about view on latency, criticality, and safety features as part of the fast-paced project implementation approach. Either one of you, maybe Geoff, if you want to answer that one, or?
Yeah, I don't know the exact root of the question, but just to talk about latency broadly, again, with a cloud system, resourcing is automatically provisioned, right? So the scale, right, that you need for your the scale and resources that you need for your particular application is going to be provided, right, by that cloud provider. So and we also can host across the world, so regional latency does not tend to be an issue.
And I'm not sure I understand what the safety features are. Fast-paced projects, all our projects are fast-paced. We're talking about getting solutions in within weeks. So we have methods as part of our composability concept. We have methods to do this. We have best practices. We have library content. So everything there. In terms of safety, I'm not sure I completely understand.
Maybe it's governance features, like built-in governance features.
So maybe so it's built-in, permissions and who can access apps and who can run apps and the collaboration between people who are building the apps. It's all built into the platform. Again, these are topics that are available in online resources, knowledge base, university, etc. And you can see some of these things. And I think we even have some webinars content around these topics.
Yeah, especially on the quality control side too. There's some specific content there.
Great. And then other question here is, does the MES also have an APS solution?
Yeah, so APS is an interesting topic. We provide, so when we say APS, typically we have to think about two things. One is dispatching, and one is scheduling. So finite scheduling is provided through our ecosystem. We have a number of partners that are specialized in providing kind of finite scheduling and other types of scheduling platforms that are already integrated with connectors, et cetera, into the platform. And they're all in our library on our website, for example, Oplit and Planius, as an example. In terms of what really matters in the shop floor is what we call dispatching, and that's obviously available as part of the apps that you build in Tulip. So ability to prioritize work orders, tasks to different stations, tasks to different people. All that is something that you build in a platform. We have library content to help and accelerate that.
Perfect. Okay, we have maybe one or two questions left, and then we can close the session. So a question here about what considerations are your customers or users taking from from a cloud-based shop floor solution and its ability to operate if connectivity is disrupted?
Yeah, Gilad, let me start with this one just to comment on a trend I'm seeing, and then maybe you can follow up. So a lot of the talking points we're hearing from our customer base is that they're treating connectivity like a utility. So just like they have electricity to their plant, just like they have water to their plant, they also have connectivity. Because they're treating it like utility, we are seeing customers, invest in redundancy systems to ensure that, that particular site always has connectivity, to the cloud, because it's often not only their shop floor operation system that may be cloud-based. It may be Salesforce, it may be their ERP, it may be a litany of other systems. And so it's kind of just becoming a standard expectation that if you're going to invest in cloud technology, you're going to invest in your supporting technology to ensure you have redundant connectivity.
Yeah, just to echo that, yes, it is an issue, and there are facilities in the world where connectivity is an issue. But again, it's becoming less and less of an issue. I mean, really, we fly in planes and you get irritated, and if the Wi-Fi on the plane does not work because you can't do your work. It's becoming a given that there is connectivity everywhere, and at the end of the day, in most cases, it really is just a matter of investment. I go to facility all day long and they say, well, the backhoe cuts the line every time they do something on the water system. Well, it's an easy problem to solve. You just need to go buy another redundant line or put a 5G station, and it's not expensive, right? So it's just a matter of building in the infrastructure that you need. It is really very, very rarely an issue anymore. And cloud systems, the MES is not the only thing that's going to the cloud. Everything is in the cloud. So you need to be able to have to connect. It's not, it's not confined to manufacturing systems.
Perfect. Well, thank you both, and thank you to everyone who attended. We'll end the session now, but thank you and have a great rest of your day.
Yeah.
Thank you,
everyone. It's a lot of fun. Appreciate it.
Bye.